Hello everyone, we are back. We are super excited to be here once again, and we are under some heavy rain here in Portugal at least. We welcome you all to another one of the xgeeks live streams. I am Beatriz, I'm part of the xgeeks team, and if you haven't heard about us before, we represent what we believe to be the balance between product and project. Our expertise is around cloud native acceleration by unblocking agility and innovation in hybrid and multi-cloud projects. If you are curious about us, you should definitely check out our social media and our website, and don't forget to follow us for more content. Now, I know nobody's here to listen to me, so I made this quick, and without any further ado, I welcome to the stage Daniel, that will be talking to us about from zero to hero in Kubernetes Native Java. So welcome, Daniel.
Thank you so much, Pia. I'm super happy to be here, and thanks for having me today. Yeah, yeah, it's a really wonderful. I'm actually based in Boston, and today is really chilly. I think it's pretty much chilly than Portugal. Yeah, so it's like
Yeah,
8
probably. We
10
are.
degrees Celsius today. Yeah, cloudy. It's a pretty normal Boston weather, though.
Okay, that reminds me to never go to Boston then, because I will be freezing.
Right.
Daniel, actually, just before I leave you to it, I just want to remind everyone they can leave their questions in the chat, and I'll present them to you for you to answer as we go. And best of luck, Daniel.
That'd be awesome. Yeah, thanks again. Hi, everybody, and good morning, good afternoon, good evening, depending on the where you are and where you're watching this video later this session. So I'm gonna showcase the how do you become like a superhero, like just like a session title today, Zero to Hero in Kubernetes Java application development. So my name is Daniel O. I'm working for Red Hat as a developer advocate with specialized cloud native runtimes, for example, Quarkus, Spring Boot, and then a bunch of the JavaScript. I've been spending a lot of time bringing the Java workload into cloud, such as serverless and service mesh and GitOps. Maybe you don't understand why the normal Java developer needed to care about serverless, service mesh, and GitOps. Because once Kubernetes come to your town and your enterprise environment, and then you needed to extend your capability as a part of your daily job from inner loop to outer loop, some part of the outer loop. For example, not only develop application, but also need to verify the application's functionalities and the capability, not only your local machine, but also somewhere out there, Kubernetes cluster. It's some of the part of the outer loop, but still one of the job, main responsibility of normal developers. That's why I pretty much spend a lot of time and put my effort into serverless service mesh GitOps integration with the Java application. I'm also Java champion, and then luckily I'm also responsible for Cloud Native Computing Foundation, also known as CNCF ambassador. It's two roles, Java champion and CNCF ambassador. Uh, give me some chance and more opportunity, meet a lot of awesome people, not only developers, but also IT operation team, or you can say full stack Java developers or application developer and cloud architect or SRE and DevOps engineer, etc. Here's my contact information, Daniel O30, all social media, Twitter, YouTube channel, or my Gitlipo. You can just go to that social media and you can ask me any question around this my specialty or some relevant open source projects. I'm more than happy to address your questions. Alrighty. So today I'm not gonna spend a lot of time with the boring slide deck. However, I try to showcase a live coding show, but before that, let me define some of the two terminology, because a lot of people actually use these two terminology interchangeably. For example, cloud native and Kubernetes native. You can actually find the two terminology in many blog posts or YouTube channels or technical tutorial or some paper books as well. So what the cloud native is? The cloud native is literally aims to invent a new technology based on cloud, which is like hyperscalers, Amazon, Google, Microsoft, or some IBM cloud and Alibaba cloud. Any kind of technology, not only open source, but also proprietary technology, was born based on cloud. As long as you're going to use that cloud technology rather than uh, invented by yourself, then you say, oh, my application cloud native. However, what is the Kubernetes native stuff? So Kubernetes is not mandatory features or core component in cloud. However, many cloud providers actually provide Kubernetes services, for example, AKS or EKS or many kind of XKS services on cloud because of that actually market trend. Everybody wanted to use Kubernetes to scalability or portability or any kind of some container environment, more flexibility or electricity. There are many benefits on Kubernetes. So cloud, you can just deploy your application, not using container and Kubernetes, but still you can make your application cloud native regardless of Java, .NET, Python. However, if you wanted to make your application more perfectly Kubernetes native stuff, you needed to think about what kind of features or capabilities Kubernetes actually provide for Java application developers. So let me try to a little bit specify and define some distinguishes between two terminologies just for my demo. So this is the one last slide today to showcase the how to make you become a superhero when you develop new Java application on top of Kubernetes. And now you can say my application Kubernetes native Java apps. So left hand side, you are a developer right now, and then doesn't matter you have like a 5 years experience or just beginner or even 20 years experience. I've been doing more than Java, maybe 25 years. I'm actually based on Boston right now. Anyway, so doesn't matter how long, how much experience do you have, but let's say you are just Java developer right now, and then you need to develop some of the application to fulfill your business services and requirements. And then when you finish your application development and need to deploy to your application to Kubernetes. And then, but even if your application design and developed by microservices, like along with the 12 factors, but you cannot say my Java application 100% Kubernetes native Java apps because Kubernetes provides many features which uh, you don't need to implement by yourself. For example, when you have some chance to go to read out 12 factors. One of the interesting part, you need to externalize your configuration rather than inside your application, like a sensitive information, username, password, or some token keys. You can also some of the property, even if not sensitive information, you don't need to save your local system. You need to save that configuration somewhere out there, out of your application, and you just report that thing. For example, Spring Configure Server, which implement this 12 factor. And then there are more capability like a service discovery, service registry, and load balancing. There are many open source projects invented by Netflix almost a decade ago, like a Eureka or circuit breaking. There are a lot of capability you have to implement by yourself, regardless of what kind of language framework and platform you want to use. This is a big burden for application developer because this is not 100% related to your business logic. It's all about some functionality, but not microservices functionality. It's more like infrastructure stuff. However, you have to make sure implement this kind of stuff to avoid some cascading failure or some unnecessary error in disputed microservice system on top of the cloud, but also Kubernetes environment. So are you guys ready to go to be like some superhero today? So here's my demo environment. So let me try to, so today I'm going to try to use uh, Quarkus because Quarkus Kubernetes native Java stuff is so actually design and develop targeting for Kubernetes, but also it provides many developer experience as well. So let me try to use Quarkus today, and then I'm going to keep explaining why I need to use Quarkus rather than the other Java frameworks such as Spring Boot or Micronaut, parallel. So there are many different ways to create a new Quarkus project. Maybe you want to go to quarkus.io here, and then here to starting coding, something like a Spring initializer. You could use the Java version, and then like a Maven or Gradle or Kotlin, and you could change the group ID, artifact ID. And one of the interesting part, you actually select the some of the application capability, for example, web application and Kafka, like a data transaction or messaging application. There are more than 650 extension. You can use that right now, which download automatically in your local system as a Maven dependency or gradual module. So when you select on, you can just click on generate your application and download zip file and unzip file, and then just open that project user ID tool. This is one of the maybe easiest way you want. But let me try to use Quarkus CLI, which is one of the fancy tool. You don't remember any kind of parameters, arguments on your Maven Gradle packaging tool, but also it's to make it easier to add a new functionality like an extension on your project directly and more obviously. So let me try to create a new Quarkus project. Let's say a project name Kubernetes Native Java. As you can see that it automatically creates like a Maven wrapper. You don't need, you could have maybe multiple Maven version to multiple projects. So it automatically generates Maven wrappers and then Docker file in case you're gonna packaging Docker images and then container images and deploy to Kubernetes, and then some of the configuration and sample application as well. Let me try to go there, and I'm going to open my application using my ID tool. Let me try to a little bit bigger. And then here's my POM XML. So the latest version 3.3 we released like a week ago. And then go to source. There's one simple RESTful API, which is an endpoint hello, and the return hello from message is reactive because the Quarkus actually built on reactive engine based on Vertex and Netty. But the good thing is Quarkus actually allows developer to implement non-reactive application, reactive application at the same time at the same class, rather than rewrite a whole thing from non-reactive to reactive application. So that's a simple application here. So let me try to run my local runtime, like a Quarkus demo, which allows me to have like a live coding capability. There's nothing in there almost 2 decades in Java world. It's only available in Quarkus at this moment. So live coding here. Of course, you can add some feature like some of the ecosystem in the Spring Boot, like a DevTools or Telebridges, and there are a few more things, and you can actually use a similar capability like a Java hotspot, something like that. But live coding, you can actually keep using this live coding. It automatically recompile, rebuild, restart, and redeploy your application behind the scene whenever you change the code. Doesn't matter Java file, property file, YAML file, XML, all kind of stuff. And then I'm gonna go to like a welcome page here, and then go to dev UI. This is a brand new one, and you can actually find what kind of extension you already have. And then compilation. It's not only your local compilation, but also like a built-in compilation as well. Let me take some time here. Let me try to reload. Here now you can see that, and then continue testing. Let me try to start continue testing. So maybe you feel, what is the matter about the Kubernetes Native Java? I mentioned earlier, as a normal developer, you need to extend your job's capability and responsibility from inner loop only to inner loop plus a little bit about outer loop as well. But you don't have your company won't give some more time and money for that. You just manage your schedule from inner loop to outer loop. So if you could save your time to develop inner loop process like a build application, testing application, and then keep a writing application, you can save time. For example, you need to spend more than 2 weeks to make that happen, but now you could have it 1 week, make the same happen. And then the other remain 1 week, you can use that for outer loop process, and then you have use the same time, same effort, but you got a much better output for inner loop and outer loop. And in the end, you could eventually increase your code profitability with the Kubernetes native application. So I just passed the test cases. Let me go back to terminal window and open new terminal here. And then let me try to a little bit bigger for you guys. And then HTTP and then 8080 port and then hello. So it's a return is the same thing. And when I go back to my project and under the test directory, the test scenario also automatically generate here. Endpoint hello and hello from that's the reactive stuff. And then that's the when I go to terminal as well, you can find the green color one task is passing. It's exactly same thing. Go to WebUI. So if you prefer to WebUI, you can go to Dev UI. If you prefer to CLI, you can go to terminal like a runtime environment. So let me go to try to add some of the logic here based on test-driven development. Everybody understand how important test-driven development is. However, you don't want to spend a lot of time to TDD because you not enough time to develop business logic only. So there's a lot of people skip that, and everybody confident my application is super awesome. However, that's not whole true. So if you could have like a TDD capability rather than using some third-party tools or extension or ID tool, whatever you change the code, and then it automatically testing your application, notify you, hey, your test failed, your test succeed. That'd be awesome, and then you can save your time. One of the big part of your inner loop process, which is verify your application like a test phase. So let me try, but for that, let me try to go back to my application. Let me change this one, like a, how to say, like Ola xgeeks. And I save a file and back to the terminal. And now you can see it's automatically show that I expected hello from message, but you actually return Ola xgeek. And then, so if you call endpoint, now you gotta have the actually same result here. And then if I then xgeeks, save a file, and then you can also that. And you can also have Ola xgeeks. It's a literally return code. This is the literal meaning of live coding. However, you instantly find out, oh, my test failed. When you go to WebUI, if you prefer WebUI, you can go to here, you're gonna same measure. So, oh, that's literally, you just only focus on application development, save your time. Let me fix that this problem real quick here. I'm gonna change the return code and save a file. And then back to the all one pass, and then go to WebUI, and all back to the green. Everybody happy right now. So let me try to add a few more logic in more like a realistic application. And then in the meantime, I'm going to keep using continuous testing as well as live coding at the same time, which is really save my time. Even if I have only almost like 40 minutes left, but I can keep doing that. So let me try to create a new one and change it to, for example, greeting here, and then endpoint greeting, and then Kubernetes Java with Quarkus, and save a file, and then back to the here, and then I have a new test case, but I got some error here, 404, which means there's a resources map to this test case. So let me go to my resource and then create a new RESTful API. I'm going to try to, let's say, new path, which is greeting, and then I just change the method name, and then let's say Kubernetes Native Java with, and I'm going to try to add some configure property here. Let me try to configure property rather than hard code value, and then name, which is like let's say name, and then here is name. I just save file, and let's go how to change the continuous testing. I got a new error here. If I go to a little bit, go down here, now I can see that I'm gonna fail to load the config value based on key name is name, because I didn't set the application property. Here is the, let's say, name, Quarkus, back to save, and then you back the here. So all test case pass, and then new terminal window, and I'm going to try to check it out, the new REST API, Kubernetes Native Java with the Quarkus, which is really cool. Even if, oh, I just implement my application, but I need to change the value, but I still prepare Web UI, and then go to configuration, let's say go to name, and then where is the Quarkus? Here, hey, here you go, name. And then maybe let me go to Quarkus 3, and then I just save a file, and then back to the terminal, and then I'm going to invoke again, and now you can have the Kubernetes Java with the Quarkus 3. What happened? Because when I go back to my local file system application property, as you can see, the web UI actually changed your local file system at the same time. However, I wish the one thing, I got some new error because based on continuous testing, which is expecting returning Quarkus 3. So let me go to my project and then go to test case, and then here to change this one, save a file, and then back to the test to succeed. So pretty awesome. This is really how I develop new application. And then if I just stop demo, and then if I just build my application, because I'm going to put in the skip unit test because I already succeeded to continue testing stuff. And then I'm going to try to open my monitor activator and then try to go to memory. And then I'm going to try to, I have a mini Java JVM right now. I'm going to highlight this one. And let me try to run. So this new Java application, and then as you can see, it start less than half a second startup, and then go to here. So new JVM, so 91 memory footprint, I got just 92, and then let me try to check the application capability. Application works, and then it's a little bit like a 2 megabyte memory, a little bit increase based on the application invocation. And then, so because when you deploy this application Kubernetes, you also need to consider how to make my application smaller and faster. Because in order to deploy application to Kubernetes, you always expect some kind of high scalability based on your huge amount of incoming network traffic. So if you needed to maybe scale out maybe 10,000 pod based on your incoming streaming, and then smaller and a faster startup time would be better. That's why serverless application more prefer to use Node.js Golang rather than traditional Java application, because Java is a little bit slower and then a heavy way to start application based on Kubernetes auto scaling stuff. So that's why I'm going to try to showcase how to make it smaller. And then you maybe heard about with the Java native compilation, which is like based on GraalVM, which allows me have like a native executable, small and fast, And the Quarkus actually designed the Kubernetes native Java app with the native compilation almost 4 years ago when we developed Quarkus very beginning. So you can make sure compare like a Spring Boot native and Quarkus native. And then I would say Quarkus native is way faster and smaller than Spring Native, almost like a 2 times or 3 times smaller and faster. So in order to build Quarkus, and I'm going to try to unit test skip and the one native compilation, because when I go back to my application and I go to POM.xml, so native profile already inside the Quarkus by default here. So you just only need to pass down native, and then which allows you packaging application as a native executable file. And if you have any experience before to use a native executable, and then you need to maybe install GraalVM based on your OpenJDK Java version. Currently, I'm using Java 17, and then relevant to GraalVM version. And then once you compile and build executable file, it depends on relies on your operating system. For example, my demo environment is a Mac OS M1, which means the executable file only running on Mac OS M1 rather than AMD 64 or Intel CPU, because it's tightly your operating system or chip architecture. Okay, I just done. And the interesting part in the logo, you can see that just 4.2 second, for 99 garbage collection. And then here's almost 3 megabyte for your memory footprint. And the CPU just 537. So with that data, so the native compilation is consume a lot of memory on your local machine. So I don't want you uh, build and make a native executable file every time you change the code. In the reality or more common practices, you have to yield this job into one of your fantastic CI/CD pipeline rather than on your local machine. So go to target directory. Now you can have a runnable executable file is a 45 megabyte. So in case when I try to develop same two REST API on Spring Boot 31 and Spring Native, it's more than like almost 100 megabyte or 95, something like that. So it's just 45 megabyte. It's not a big deal on file size, but just imagine that if you need to deploy this application to Kubernetes and then it scale out maybe 1,000, maybe 10,000 or 100K, and then it's all about your storage issues, and then you spend a lot of money. So not only like a developer concern, but it's more like an operation concern though. But you need to make sure your application smaller, faster, as long as you need to deploy application to Kubernetes. Okay, so let me try to run the application. And now we can see that 27 millisecond, 27 millisecond, which is like a 11 11 times faster than like the previous JVM stuff. The JVM application is still less than half a second, like a 400 or something like that. It's more like a 15 times faster startup time. Go to memory footprint, and now you can see 14. Previously 91, 92. It's almost like 6 times less than memory footprint. When I try to endpoint invocation again, just to make sure application working, Kubernetes Java with the Quartet 3, and the memory footprint is just when 1 megabyte to slightly increase. It's still small memory footprint rather than Java application stuff. Okay, so now I'm gonna try to go back to run again Quarkus there because I need to add more business functionality. And then let me try to really quick check the YouTube channel. Is there any interesting question in there? Okay, I don't think there are some questions. Alrighty. So let me try to run Quarkus dev again. And then I'm gonna add, let's try to JDBC PostSQL and Hibernate ORM and then Panache and REST easy for Jackson for JSON format parsing and descriptor. When I just check my Docker process and there's nothing in there running process, and then JPA integration, something error. Okay, let me try it one more time. Now you can see that it automatically PostSQL container automatic standard based on test container. So everybody maybe just in case you never ever heard about the test container before, the test container, the main goal and idea is to get rid of some gaps between your local and production. So whenever you develop, for example, data transaction logic with the Java application, you pretty much try to use H2 in-memory database or just connect to remote database. But sometimes the remote database doesn't allow you to use that because that company security policy, one network policy, etc. But even if you verify your application capability and functions, but sometimes it doesn't work in production, which should connect to real PostSQL database. So test container is automatically stand up relevant container image as long as you set up relevant like a Java extensions or like a Maven dependency and some of the required configuration on your application properties or YAML file. It automatically stand up. You don't need to use Docker command, or you don't use podman command, or you don't need to write Docker file at all, which is really convenient. So Quarkus Dev Service is actually built on test container. You don't need to even add some test container configuration or dependency on your Java project. we could say literally zero computation. It also another opportunity, save your time, more focus on application writing rather than the other, like a setting, reading documentation, etc. So let me go back to here, dev UI, and then go to like a dev services. Now you can see a new dev services here, PostSQL. It automatically set up all computation, like what is my DB kind and the JBS URL and username password. However, when I go back to my application and go to properties, still nothing in there. So that's why I would say zero computation. And you don't need to remember key and values. You just copy key. Oh, I don't want to use Quarkus as the password. You could just copy, and then my password is something like a super secret. And then it automatically rewrite and override your password. So let me give it a just default here. Okay. And then I'm going to try to add a few more Java logic here, like a person, which is my entity, and then Panache entity, which is just the integrate new code project, integrate Hibernate ORM, like a SQL mapping. It's a similar way to implement the JPA, like a Spring JPA stuff. However, you don't need to implement all interfaces for fundamental operation, like a getter setter, and then like a retrieve all data and persist data, what delete update, just like a CRUD capability. Is Panache entity actually extend the Panache entity base, which already implement all like a CRUD capability as a function, common fundamental operation, delete, like a persist, update, insert, things like that. You just use that. So pretty much easier and save your time again. Another reason why you maybe consider to use Quarkus for your Kubernetes Native Java app there. And then I'm going to try to add a few attribute here, like a name. And then another thing is my location. That's it. This is my entity. And I'm going to try to add a new RESTful API here. Let's say let's API person. I'm going to return like a JSON rather than a text type. And then let's say list all, and then return the list array list, something like that, and then person object. All right. And then my entity already have a list of all method based on Panache. That's all. I just created one RESTful API, retrieve all my data from my database using this RESTful API. Let me try to add one more thing here. And then let's, I'm going to need to search my person data based on unique ID here. It will be only written one person data set. Let's say a new name, like a find by ID, and the path param, which is like ID. It could be long type ID, and then find by ID, also implement by Panache. That's it. I just created two methods. I just took like a 25 seconds to implement two business logic. And then let me try to add a new DML SQL file, like an import SQL. So one of the good thing is Quarkus on Hibernate ORM Panache, which automatically create database schema and table based on your entity class. So I create a person as an entity class, which means Quarkus automatically creates a person like a database schema and a table automatically based on their attribute with your file name. So you don't need to create a DDL SQL file that create a table and create like an index or something like, and sequence as well. You only need to like if you need like insert DML. If you have like a post RESTful API to insert some of the data, even if you don't need to use DML SQL file. But in this case, I'm going to showcase some more common practice. So you already have your own data at the very beginning. Let me try to using insert SQL query, insert into person, which is the value. But by the way, Quarkus 3 support Hibernate or the Hibernate ORM 62 version, which is a very good features and a tremendous enhancement compared to previous version Hibernate ORM 5. And then here's my sequence and my paper name. Then I'm actually from Boston, currently on 1:36 p.m. here. And then let me try to add two more. Here's another sequence. And then Justin from San Francisco, Jenny from, let's say, New York City. Okay, I just save a file, go to terminal. Let me try to access the endpoint again, finger crossed, and person. And now you got a 3 result. And if you try to find the number 3 ID, which it could be Jenny, that's it. So I just I just spent like a 5 minutes to implement new CRUD capability on my application. I don't need to recompile and then redeploy and then create a Docker file and then running on some Docker stuff or test container. I just keep focusing on my writing application, which is to save my time, and then I will use that spare time to make my application Kubernetes Java app, which is increase my application quality and make it secure on Kubernetes environment. So let me try to deploy this application to Kubernetes first, just to make sure the application function exactly same on my local as well as Kubernetes environment. So here's my Kubernetes environment today, the Red Hat Developer Sandbox. My namespace DOH-dev is empty project. If you go to developers.redhat.com, and then there are here technology. Here's our developer sandbox, and then you can actually go to developer sandbox. Once you sign in with your valid email address, the Red Hat provides a free Kubernetes cluster for next 30 days. And it's not only Kubernetes cluster, and there are many kind of operator already installed for serverless or even IoT stuff, and then some OpenVINO for AI ML or machine learning, and then a streaming. There are many kind of operator already installed. You just consume their existing resources. You don't need to install by yourself, and you don't need to go to public cloud to pay for XKS services. So pretty much easier. Just sign in with the email address and just use that. I'm just using the same thing here today. Let me go to Kubernetes namespace. Just make sure DOH-dev, which is here. And then let me try to go to Quarkus build. You note that I need to add OpenShift extension and Kubernetes config. Let me try to explain why I need to add the Kubernetes config extension. That is allows me to make my application better Kubernetes Native Java app in the end. But OpenShift extension, which allows me to build and deploy application Kubernetes directly. I don't need to write a Kubernetes manifest like a YAML file. It automatically generates that YAML file based on my application property and topology. So let me go back to my application first and then go to property. And I need to add real compilation to PostSQL. I'm not going to using dev service anymore, my local machine. I need to access the real database somewhere in the Kubernetes environment. Let's try to add a new PostSQL here. Let's say the database just name and the schema name person. I'm going to create two new database, drop and create. And then this is all production environment and the username user, and the password is super secret. And also load the script here, which is an import SQL file. That's it. That's all compilation around PostSQL. And let me try to add Kubernetes compilation. I'm going to deploy this application to Kubernetes, true. And then while you're targeting deployment target, you can say Kubernetes. I'm going to use OpenShift today. You can say Knative, which is to make your application serverless as well. And then I'm going to expose the route URL based on HTTP proxy, HA proxy. So you don't need to use ingress nginx stuff. It automatically generate fully qualified domain name for end user to access your application, like a web UI, something like a RESTful API, things like that. And one last thing is the opportunity cluster by default is the self-certificate for TLS termination. So I'm going to make it true to access to through self-certificate TLS termination. That's it. I think that's it. And then let me go back to terminal window, and then I'm going to try to Quarkus build. I'm going to skip unit test at this moment. And then back to my Kubernetes cluster. Let me try to add a real database at this moment. Go to PostSQL. Here, PostSQL. Let me try to bigger. And then it's a person. And then the username user and the password super secret. And once again, database name, person. And now you can have the database and then add the label just to make sure this is a PostSQL. Now I have a PostSQL database. And back to the project terminal window. Now I'm going to build an application. When I go back to my project under the target directory, and then you can see that Kubernetes directory automatically generate, and there's a JSON on YAML, which allows to automatically generates your Kubernetes manifest, like a service account, which is rely on the opportunity cluster, but the role binding and service and deployment is all about Kubernetes manifester plus OpenShift manifest and resources. That's exactly what I'm saying. I don't need to write just a bunch of the YAML stuff manually. It automatically generate, and then luckily Kubernetes already OpenShift integration feature, which I don't needed to run kubectl with that YAML file because the Quarkus automatically call Kubernetes API based on this YAML file execution. Okay, build success, and then back to the web UI. And now I have a Quarkus application here. Maybe you can add some link here, and then go to pod, and now you can see some data automatically generated, and then you can see that profile product activity. Previously in that mode, you can actually saw that live coding and dev mode activated. Let me go back to terminal window. But for that, let me try to copy the route URL. Let's copy the route URL back to the terminal, and then let's say to hello, which is the Ola xgeeks, and then greeting, which is the Kubernetes Java with the Quarkus 3, and the last thing is person should be 3 result here, 3 result. If you call first one, which it could be Dan from Boston. So I just confirm my application totally working from my local and production. In the meantime, I spend very limited time develop business capability like a data transaction from my local machine to Kubernetes. My job is almost done. So because of my application totally working on Kubernetes, I actually done in a loop, but also out of loop. I just except for like I just skip it, like push the code and then like a committee code. However, I just verify there's some inner loop. I'm part of the outer loop right now. However, I cannot say my application. Maybe you could say cloud native app, but you cannot say your application Kubernetes native application. When I go back to my application and application property file, I already have like a static value here, username, password, like a secret information as well. And then my computation from reading my local file system, which is not good practices because Kubernetes provides some Kubernetes ConfigMap, which allows you store computation out of your application. And Kubernetes also provides a secret, which allows you store sensitive information out of the application as well. Let me try to add that. In order to that, that's why I actually add Kubernetes configure extension just a little bit earlier here. Kubernetes config extension which allows me to do that. Let me go back to here, and then, but for that, let me try to add like a secret first using like a kubectl. Here is a username user, and then password is supposed to be just exactly the same thing. My application side here. And then you can also go to WebUI if you prefer to use WebUI, and go to secret and DB credential, and you can rebuild the values, and then password, secret, username, user. You can also create the ConfigMap on WebUI. For example, let's say my config name, my config, and then let me try to delete this one. My config name is Workers 343. I just save file. And then go back to application, and let me try to add a few combination which allows me to access the remote Kubernetes resources from my application directly. In order to add Kubernetes ConfigMap, which is my config, and then ConfigMap enable true, and then the secret, which is a DB credentials, and then secret enable true. That's it. So it's a 4, and then let me try to delete that hard code secret information and then report to Kubernetes resources. In order to that, let me try it here. Key is the username, and the password, which is also password key, and then go back to application side. The key is my config name. Okay, that's cool. And then in order to deploy this application, again, let me try to give you some very interesting stuff here. So one of the beauty of the container technology running on Kubernetes is to provide portability and immutability. If you could change some of the content inside the container, it will be rolled back when the container restarts. So that's the, we could say, immutability. But sometimes you got some issue, an error in the runtime environment in the Kubernetes, and then it's really hard to troubleshoot that error because you got some error, Kubernetes automatically kill the pod and the restore, just like a self-healing or replication capability. But your logs already gone. But sometimes you have a big giant log file system, which aggregate all logs, and then it's not easy to access that centralized log infrastructure by individual developer. So you might need to open the ticket and then waiting for a couple of hours later, or even a couple of days later, you can access that. There are always tons of the logs. It's not easy to investigate, but also sometimes it's a time, like a very urgent problem, and then you already lose opportunity to fix the problem in based on your SLA. If you could investigate your error in a real-time environment, like a Kubernetes, just like your live coding capability on your local machine, to come up remote to Kubernetes cluster, which is perfect, and make save your time to make your application more Kubernetes native app in the end. So Quarkus actually provides some change the packaging type, package type, which is you can change immutable, not immutable, and then library load password, which is only between my local and the remote Kubernetes cluster, library load, and URL, which is endpoint of the Kubernetes cluster. Here, this is the endpoint. Alrighty. And then one last enable the remote demo, the Quarkus OpenShift environment bars Quarkus launch demo and true. Okay, that's cool. Hopefully there's no typo at this moment, and go back to here, and then let me try to run once again Quarkus build, and then just skip unit test, a little bit save my time on my demo environment. Okay, and then it takes maybe less than 1 minute to deploy the application again. So let me give you some another interesting stuff to save you more time and make some spare time to focus more on improve your application with Kubernetes native way. So Quarkus project automatically generate Docker file here under the main directory for like a JVM or the native compilation. So you don't need to even write a Docker file to containerize your application in case you want to checking your application functionality or functions with the containerizing. And then not only JVM, also legacy jar. So Quarkus actually override overall the Java class loader, which make a Quarkus application really faster than any other Java framework. That's why you can see that like less than half a second with the jar file. However, that actually different directory structure. It actually generate the Java file under target and then Quarkus app directory is the second layer. However, sometimes you have some infrastructure which only allows to run your Java file right on the target directory, just like a general like a fetch jar or Uber jar. In that case, you can use this Docker file like a legacy jar and native for compilation, etc. Let me go to the terminal. It's already done, and then go back to my Kubernetes cluster, and then check it out, the view logs, and then the data is created. And then one of the interesting here, now you can see that here, profile dev activated, live coding activated, not like a production. Okay, that's cool, looks good. And then go back to here. Let me try to access to endpoint first to greeting, which was previously Kubernetes Java Quarkus 3. It should be returned Quarkus 3.3, like this one, because not my local file system is a Kubernetes ConfigMap. And also, you need to return 3 data, like based on secret, which is the DB credential store Kubernetes secret, username, password. So still working. So now I can say, oh, my application pretty much good at, Kubernetes native stuff because I'm using service discovery based on Kubernetes service. And then I'm using like some router, which is like a fully qualified domain. And also I just store sensitive information in Kubernetes secret. And also I externalize my configuration now from my application property to Kubernetes ConfigMap. It's a way better Kubernetes native Java app rather than without this capability and integration. And one last thing is, let me try to run once again Maven Quarkus remote to dev. It's a Quarkus demo, exactly same thing almost, except for try to connect to remote Kubernetes cluster based on password and then the URL. Now you can see the new node connect to remote server. Let me go to the application, and then if I add a new like a SQL file, like a number 4, here is the let's say my friend here VR, and then she from Portugal, and I just save a file and back to the terminal, and then go to call person and then back to the local, and then Quarkus automatically detect the change the file and the sending to Kubernetes cluster, and now you can see that the new result just came from remote Kubernetes cluster, not my local machine. So it's really, you can have the same capability like number 4, which is the same thing here. Even it's not SQL, you can change anything just like a live coding. And then it's pretty much making your environment like a more prepared, more fitting in the Kubernetes native environment. Let me try to change one more thing. Go to my application property. Let's say like a Quarkus to like some for in the future, Quarkus 4, and then application. I'm not going to using CompuMap. I'm a local machine, just a quick test. So I just change my Java class and also property at the same time. And then if I check it out, greeting, and then back to terminal logs, and you can see that here is greeting Java class change that, and also property change that. And then go back to here. Now you can see that Kubernetes Java the Quarkus 4. And so you can change anything. It makes your more good capability to make your Kubernetes Java app. And not only writing application or enhance your capability along with the Kubernetes capability, but also you can really real time troubleshoot and live coding capability from your local to remote Kubernetes cluster. You can also connect to the live debugging as well, as long as there are some network permission between your local with some specific port, like a 5005 between your local to remote Kubernetes cluster, like a port forwarding from your pod environment. So let me go back to that's what I will showcase today. Let me try to just summarize today's talk. I'm gonna recheck my YouTube channel. I don't think there are any question in there. Okay, so I already create a similar video, and then there are more than like a Quarkus, like a Kubernetes or like a serverless and a GitOps, all my specialty. You can go to my YouTube channel or the bit.ly URL Daniel TV and feel free to subscribe and then ask any questions or any ideas. Hey, Daniel, I need to run something new around Java application with integrate like Argo City for my GitOps practice. And then can you give us some quick example with your Git poll and then quick like a 10 minutes, less than 10-minute video tutorial? Sure, I'll put it on my list to create and post it. So feel free, reach out to me with my social media, Twitter, and then YouTube channel, and then ask anything. I'm happy to help and happy to address your question. That's it. I think so I'm going to hand you over back to BR. If there are any,
Hi.
yeah,
Yeah. Yeah, awesome. Thank you. Thank you so much, Daniel. We just wait a few extra seconds to see if anyone asks any questions last minute. But thank you so much for including me. I was very nice to be included in that
sure, yeah,
presentation. Awesome. So, Daniel, I guess if we don't have any questions, it's because you were so clear with your explanation. So don't worry about that. And thank you so much once again for being here today. I'm going to go ahead and also say goodbye to everyone. Oh, wait, Daniel, we have one
sure.
question.
Oh, yeah. Okay, the question from Andre, how do you compare Quarkus with the Spring Boot beside the Kubernetes part, which is of course the main course? Yeah, that's a really good question. I've been asked a lot with that question, many like a Java developer and Spring developers. So I wouldn't say the apples comparison. So Quarkus actually was designed and developed with different purposes, not only Kubernetes, but also more like a make a smaller, tiny for event-driven application with serverless and like a more uh, increased developer productivity, as I showed today, live coding, continuous testing, and dev services, and the dev UI and the Quarkus CLI, all kind of Quarkus feature enables the Java developer to make their life easier, quicker, and funny. So my colleague Eric Andrea and I wrote the ebook in Quarkus for Spring Development. Let me try to put in the URL. Give me 1 second. The Quarkus for Spring Developer, and then you can actually download the book for free. Let me try to put in the. Oh yeah, that's cool. Just a quick sharing. You need to go to here and then just download the PDF file. So in this book, there's nothing about Quarkus is better than Spring Boot. But this book showcases some of the common use cases, for example, how to develop RESTful API application, or how to develop data transaction, messaging application, or cloud environment integration, something like that. All each chapter showcases specific use cases, and then each use case is explain how Quarkus develop, how Spring Boot develop with sample code. We also have a public Git repo. Anyone can access and fork and then reiterate on your local machine. And then we're gonna let individual developer decide which framework would be better for your purposes and your needs. So I would suggest to just download and read this book, and you can find the answer. because it depends on the which cases you want looking for. So some of the cases, oh, Quarkus is pretty much better than Spring Boot. But however, some of the cases, oh, Spring Boot is way better than Quarkus. So that's why I'm not going to say Quarkus is better than Spring Boot, but it depends on the what kind of workload and use case you want to implement on your business application.
Awesome. Thank you, Daniel,
Sure.
for your answer, and also thank you once again for your presence here with us today. So to everyone watching, thank you also for taking time to be here with us today. Oh, wait up! I'm going to bring you back, Daniel. We have one more question.
Yeah, does using Quarkus removes the need for ham chart? Uh, no, absolutely not, because ham chart is a totally different purpose to generate some of the manifesto, like a Quarkus object extension generate that kind of stuff. But the Quarkus actually ham chart extension. So once you add ham chart extension in Quarkus, and then it created like a ham chart, like some chart YAML file, like a provisioning, unprovisioning some YAML file based on your application property and then your application setting. And then you can just reusing that ham chart YAML file into any Kubernetes cluster. But OpenShift extension is focused on Kubernetes rather than like a ham chart, the YAML manifesto. So it's maybe complementary, like some capability, but Quark is actually not removing ham chart capability, not replacement at all. Hopefully that answer for
Awesome.
you. Yep.
I think we did answer that for him. Thank you so much, Daniel. And thank you once again for everyone watching at home. And I hope to see you guys in our next live stream as well. Bye bye, everyone.